let's apply the reduction formulae again. So I'm going to give you an identity. It says sine of 180 plus theta, or plus a, right, multiplied by, that's a multiplication sign. I'm going to try and color code this example, multiplied by tan of negative a, multiplied by cos of a, let's try and use blue, okay, all divided by, let's just put a line through that, all divided by cos squared 90 plus a. Okay, so this one seems to have a co-ratio in it as well. All divided by cos squared 90 plus a. Okay, now before we continue, I just need to point out, when we get something like cos squared a, you need to know that this is exactly the same as saying cos of a all squared, right? The reason we do this, we use this notation putting the square on cos, is so that people do not confuse this with cos a squared, right? Because here, this could be that a is actually being squared rather than the cos of the angle. Okay. So let's just go one back and let's see. So the question given is exactly like this, and we say, okay, is equal to 1. Okay. Is equal to 1. So as I promised, I'm going to color code this. Let's just use brown. I want to indicate that everything you see on this side is what I call the, what is this? I call this the right-hand side, RHS. And everything that's on this side, I call the left-hand side. Okay. Now, we are going to simplify each of these. When you start a question like this, you need to lay it out properly. So you start off by saying left-hand side equals, and let me use a color that is not in there. There's blue, sky blue, red, and that, so I'm going to start off with black. I'm going to say left-hand side is equal to, and I write down the question, right? So you write down sine of 180 plus a. So sorry, just for the sake of copying down the question exactly, I'm doing it in black without actually color coding it. I know I promised I'm going to color code it. All over cos squared 90 plus a. Okay. Now let's say that is actually equal to, let's start off with sine of 90 plus a, and that's why I'm going to work in red, because I'm only simplifying this right now. So sine of 90 plus a, sorry, sine of 180 plus a, we need to identify which quadrant that is in. And if you go back to your summary sheet, 180 plus theta or plus a occurs in the third quadrant. Sine in this quadrant happens to be negative because only tan is positive in that quadrant. So let's go back here. 180 plus a is third quadrant. That's in the third quadrant. In the third quadrant, we find sine is negative, so it becomes negative sine of a, okay, in terms of the acute angle. Okay, so I'm going to go back here and I'm going to put this thing down as negative sine of a. Now that's going to be multiplied by tan of negative a, and let's just put in the sky blue, tan of minus a. Now, if you've gone through the previous videos that you've been asked to go through, you'll notice that we find something called coterminal angles. Okay, and with coterminal angles, we use it to get rid of this negative angle because we never want to work with a negative angle. So for the negative angle, I'm going to first simplify that as tan of plus 360 minus a, and you should know why this works. Okay, now you identify 360 minus a, and 360 minus a happens to be in the, this angle now occurs in the fourth quadrant, right? And in the fourth quadrant, tan happens to be negative, so it's negative tan of a. Okay, this becomes negative And remember, it's multiply now, negative tan of A. Okay, and multiplied by cos A, which we can actually leave as cos A, so I'm going to put that in blue, because that's already an acute angle that we see over there, cos of A. Okay. Now, cos squared 90 plus A, this is something to look at. When you see 90 plus A, you already must know that that is a coratio, because we will only apply the coratios when we see it. Now remember, this is actually cos squared of 90 plus A, which is the same as saying cos of 90 plus A, that whole thing being squared, right? So I'm going to simplify this inside, and when I see it's a coratio, because I know it's not 180 minus, I know it's not 180 plus, I know it's not 360 minus, but I see it's 90 plus, so I know it's a coratio. This occurs in the second quadrant. Now you remember, with a coratio, you take the sign of the original function, right? Will it be positive or negative? You need to look at what's originally here. So originally I see cos. So cos in the second quadrant is negative, so I put down negative. Now I change the cos into its coratio, which is actually sine, and I take the A. Okay, I take the acute angle that has been added to it. Negative sine of A. Okay, so let's go back. Cos squared 90 plus A. Cos squared 90 plus A. Remember, this is in a bracket. Squared. Now, if I square this negative, I'm going to get a positive, and if I square sine A, it becomes sine A, the whole thing squared, which is actually sine squared A. Okay, so that's what I'm going to write down for cos of 90 plus A in green, so that you know that's what I've simplified. This thing over here simplifies to positive sine squared A. Okay, now what I can do is I can easily just multiply out all the negatives. So I got negative times negative, which gives me a positive, multiplied by positive, it's a positive, divided by a positive at the bottom. My entire answer will just be positive. That's a good thing. Okay, and now I can actually use the grade 11 identity. So I'm going to put down negative sine, the negative is gone because I've already multiplied all of that out. I've got sine A, okay, all divided by the tan A simplifies into sine A over cos of A, and cos A, which you can clearly see over here, is already cos A, right, which is the same as cos A over 1, divided by sine squared A. Okay, clearly you can see that the cos A cancels with the cos A. That leaves me with sine A multiplied by sine A, which is actually sine squared A, divided by what I have at the bottom, which is sine squared A, which is equal to 1. Now I've concluded that I've got the left-hand side, which is this whole thing. I've simplified it by reducing it. I've got an angle that is greater than 360, less than 90 now. And now, since I've done that, I can easily see, using grade 11 identity, certain things cancel out, etc., etc., and I end up with 1. And that's what we were trying to prove. I've now shown that the left-hand side equals this, which is equal to 1, which is equal to the right-hand side. I've now proven the identity, and my job is done. Okay.